Yeah, no problem.
Are you able to see if we're recording or not?
Yeah.
Oh, okay. Well,
Yeah, it says live at the top right for me.
All right, cool. Well, thank you for reminding me. All right. So, did you find anything difficult in this part?
Some of it I don't understand a ton, but I'm not sure.
We're getting more into the formulas and stuff. I wonder how much of this we have to memorize the thing, because there's a lot to memorize. Okay, so how do you want to proceed? What do you need? Do you want some explanations on some things, Cami, that you don't understand?
I mean, I just didn't really look at it a ton as well, just because I was trying to set up this thing.
Okay.
That was just not working. It would have kind of got it working, but I'll get it once I just like look into it more.
Okay. So do you want to just go ahead and do the quiz? Should we just go work on that?
Okay.
Or we can go over the problems on the part 2. What would be most helpful for you?
We can just do the quiz. That'd be fine.
All right. Let me pull that up.
Oh, my Word finally opened.
Okay. All right. So, okay, so for this, we're going to need the normal probability applet. If you have yours pulled up, otherwise they have the link to it there. And we need to round to 3 decimal places. Not until the calculation. Okay. The total, so question number 3 is the total area under a normal distribution curve must equal.
Not just the 0.373.
No, the total area
Oh.
under that bell curve. Do you know the answer, Alex?
Sorry, my like web browser just crashed.
Oh. Okay, so it's 1. The total area has to equal 1.
Okay.
So any portion of it, it's always going to be in a point, whatever, unless it's the whole thing. So the whole thing has to be a 1. It's like what did we learn about last week that had to be 1? The probability, all the outcomes of a probability had to be 1. So I think that the normal distribution curve represents all of the probabilities. So that's the 1 there.
Okay.
Question number 4. Are you with us, Alex?
Yeah, it just came back up. Sorry about that.
No, you're fine.
All right, so under certain circumstances, a normal distribution curve can drop below the x-axis.
I don't know.
I don't think it can.
Is that the no? Like, is that on the graph? If you have the graph, if it drops below the graph, or because there are negative z-scores, so I don't know if that means I didn't ever hear them refer to anything with the x-axis.
Yeah, I don't think it can because I thought that it was like using asymptote at the x-axis. X-axis.
I'm gonna go. I've got the lesson pulled up here. Business nature. Oh, the density curve always lies on or above the horizontal axis. So you were right. That is false.
Okay.
Number 5. You there, Cami?
Yeah, sorry. A normal distribution curve is symmetric. It's true.
Yeah.
Oh.
Okay, so use the following image to answer the next 2 questions. All right, which of the following elements of the figure represents the z-score? That would be C.
Yeah.
Don't start that yet, Alex.
Oh, that wasn't me yet.
Oh,
sorry. Yeah, that was the.
I don't have it pulled up to see who it was. All right, number 7.
Uh, you want me to read that one?
Oh yeah.
All right. Which of the following elements of the figure represents the probability that the z-score will be greater than 1?
And that one B.
Yeah, I would say B.
Okay. Yeah. Yes. Sorry, I was looking at the wrong thing. Okay. And number 8.
Is that one me?
Yeah.
According to the 68, 95, 99.7% rule, what percentage of the data from a bell-shaped distribution will be within 1 standard deviation of the mean?
Did you get to that point?
It's not 60.
Yeah.
68 one.
Yeah, it's the 68. With that, it's just easy. 68 is within 1% or within 1 standard deviation. The 95s, which is within 2, and then the 99.7 is 3.
Oh, okay.
Number 9, suppose that z-scores come from a standard normal distribution. Use the probability applet to answer this question. What proportion of the z-scores will be between -1 and 1? That should be the 68.
Yeah.
The z-score represents how far away from how many standard deviations away. So that would be 0.68.
It'll be 0.683.
0.683?
Go on. Yeah.
Going, okay, good job. Good catch. All right, Alex, you're up.
Suppose that z-scores come from a standard normal distribution. Use a normal probability applet to answer this question. What proportion of the z-scores will be between -2 and 2?
So that one is 9.955, right?
Yeah.
All right, Cammie. I'll do the next one, Cammie.
Sorry. Suppose that scores come from a standard normal distribution. Use the normal probability applet to answer what proportion of these scores will be between -3 and 3. So that would be 0.997.
Yep.
Yep. Yeah. All right, number 12. By the way, I don't know if Dylan dropped out or what. I keep sending him emails, so I don't know what the deal is.
I'm not sure.
Look carefully at your answers to the last 3 questions. What do you observe? I would say that the values match the 68, 95, 99.7.
Yeah.
Yep.
Okay. Alex, you're up.
All right. Use the following information to answer the next 6 questions. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. The population mean protein requirement for adults is 0.65 grams per kilogram. And the population standard deviation is 0.07 grams.
Okay.
What proportion of the population have a protein requirement that is less than 0.60? You can answer as a decimal, 3 decimal places.
Okay, so we have to figure out the z-score from that 0.60, right? So we have the 0.60 minus the standard deviation, which is 0.07.
Yeah.
Divided by the, the mean. Really should mean, minus 0.65, sorry. 0.65 and then divided by the 0.07. Is that right?
Yeah.
Okay, so calculate that. 0.6 minus 0.65 divided by 0.07. So I come up with 0.714.
Yeah. And then,
Yeah, that's what I got.
And then we want to figure out how much is above or below that.
Less. That is less than 0.60.
That's less than 0.6. So then we got to go the applet. And we put in the 0.714.
so wouldn't it be the 0.238? Am I wrong?
So it's the negative. So do we go off of the negative one or the positive one?
I'm not sure.
Because the 60, let's see. I need to go back to that. The 60 gram, let's see. That's right. Portion of populace have a protein requirement that is less than 60. Okay, so the 60 grams was at the negative side, so it must be from the negative one down. Yes?
Yeah. Yeah.
Okay, so that one is, I have 0.2376.
Yeah.
Yeah.
So 0.238, yeah.
Okay. Give that a go and see. Okay, number 14.
Okay, and this one's just what proportion of the population has a protein requirement that is more than 0.60. So we just need to just do the one above. Is it so it's just above the negative z-score, or is it above the?
It should be above the negative one.
Okay, so just be 0.762.
Yeah.
Okay.
Okay. Okay. 0.762. Okay, so then 15, what proportion of the population have a protein requirement that is less than 0.7? Okay, so 0.7 minus 0.65 divided by 7 equals 0.05. So that's going to be it's the same number except it's above the positive one. So it said what was it?
Less than.
What proportion of the population have a protein requirement that is less than 0.7?
So just be anything less than the positive z-score, right?
Yeah. So that's the 0.762 because it's just the opposite of the other one.
Yeah.
Did I do that right?
I think so.
Yeah, that's what I got too.
Divided by 0.07 equals 714. Yeah, it's got to be it. 0.762. You're tricking us. All right, Alex.
Find the probability that a randomly selected person will have a protein requirement that's between 0.6 and 0.7. And then it has a hint.
Okay, so this one we find out by, we take that 0.762, right? And then we do, because we have to take the number from what's left of the one z-score minus what's left of the other z-score. So the other z-score was the same. So then we take that off. Minus the 0.237 or 238. Are you following me?
Yeah.
Am I doing that right?
So you're taking the original z-score and subtracting it, or are you just taking that?
To find it between the two, you have to take the positive z-score of one number, which in this one the z-score is the same. It's just on the different sides. So we have to take the one that's all the amount that's left of the positive z-score minus what's to the left of the negative z-score. And then we find out what's between that. Minus, so it's the 0.762 minus the 0.238. And we come up with 0.524. And actually, we could even just highlight what's between the two because they're the same. And that comes out to 0.524 or 525 if we go by the applet.
Okay. So would we just leave it as 0.525 or would we make it a percent?
Yeah. No, it should be the 0.525. Should be. From what I remember of what I do. Okay. Is it my turn or is it your turn, Cami?
I don't remember. I can remember. Find the 35th percentile for the protein requirement for adults. Round your answer to 3 decimal places. I honestly don't know how to do that.
Okay, so do you remember how to do this, Alex?
Let me try to figure it out real quick.
Okay. 35 percentile.
For adults.
Oh, I remember. Okay, I remember how to do this.
Is this one of the formulas?
So this one we have to go to the probability applet. We have to highlight everything to the left of the positive z-score, and then we put in the area, we put in the 0.35. So that gives us the highlighted portion of the 35%, and then that gives us the z-score for that at the bottom.
Okay.
And then we use the z-score to figure out what the protein requirement would be.
Okay.
So we take the z, we plug in all the numbers from the formula. So now we're finding out what x is. We have to solve for x. So I think it would be that negative 0.385 is the z-score equals x minus 0.65 over 0.07. Is that making sense to anybody?
Wait, what was the first one you said?
Okay, so the first thing you do is you go to the normal probability applet.
Yeah.
And you highlight everything left of the positive z-score.
Okay.
And then you put in the area, you put in 0.35, because that's the 35% that we need.
Oh, okay.
And then when you do that, it pulls up just that the blue shaded area is to the left of the negative z-score.
Yeah.
And that's negative 0.385.
Yes.
Yeah. Okay.
So then you take that, and in the formula, z equals x minus the mean over the standard deviation.
Oh, okay.
And then you plug in the z-score and the x minus the 0.65, which was the mean of the protein requirement. And then the standard deviation was 0.07. And then we have to solve for that x. So we first have to multiply it by 0.07, both sides. We have negative 0.385 times 0.07 equals 0.02695. And then you have to add the 0.65 to each side. Okay, so I come up with x equals 0.623.
Okay.
Did that make sense to anybody?
No, yeah, that made sense.
Okay. Is that what you came up with, Alex?
Yeah, it is.
Okay. Okay. Now we need to find the 80th percentile. So I'm going to let one of you run that one. Who wants to do that?
I can. I just
So for this one, do we go from So when I put in the 80, it says that it's everything left from the positive 842.
Uh-huh.
So is that our Z then?
Yep,
This
so
is
that's our
0.842.
Z-score is the 0.842. Yep.
And so the equation was x minus, sorry,
So the 0.842 equals x minus 0.65 divided by 0.07.
okay, gotcha. So I got 0.709.
That's
That's
what
what I got.
awesome. I like it when we all get the same answer. Let's hope it's the right one.
Alright.
Okay, and now we can submit and see if we got them all right.
Alright.
I like when they have multiple choice.
Yeah. And 24.
Awesome.
We got it. Good job, guys.
All right.
Thanks for your help.
Okay. So what's that?
See you Tuesday.
Yep, Tuesday at 10.
Sounds
We will see
good.
you then. Have a nice weekend.
Thanks, you too.
All right.
Bye.
Yep. You too.
Bye-bye.
Bye.